Make sure.
Hi guys, welcome to the Revive Stronger podcast. I'm your host as always, Steve Hall, and I'm very happy to present to you the guest today, who is, I want to call Brad Dieter so much. I want to call him Brad Dieter because it would mean so much in terms of, dieting and what we're going to be talking about. And because I'm English, and when I see the last name written how it is, I want to say Dieter. And people know I'm awful with names, but it is Brad Dieter, right?
Yes, it's of German origin and German heritage. So, but the irony is not lost on me. I wake up every day and get a good chuckle out of it. So I don't know if it's like self-determination or total random cosmic luck or something, but yeah.
It works. And yeah, Pascal was like, because Pascal's obviously German, he was like, I'm pretty damn sure you shouldn't call him Brad Dieter. I'm pretty sure that's a German last name. So he'll be happy that you've now confirmed that he was right. But to introduce Brad quickly to everyone, so you can kind of know why I've got him on the show. Obviously, we only have kind of experts in the field on the show, and Brad is certainly that. So Brad has an MS in biomechanics and a Ph.D. in exercise physiology. So no mean feat to have both of those under his belt. He runs Science Driven Nutrition, which is a brilliant online platform, which hopefully a lot of you have actually already heard of. You may not have heard of Brad directly, but you might have actually seen the work done by him on there, because he has some amazing blogs, which I can definitely recommend. And I'll make sure the links to that website in the kind of description below, so you can go check them out. But Brad has also done a lot of research in kind of biomedical fields and examining how nutrition and metabolism impact disease. So very interesting there, but kind of is very much related to our kind of audience, which are physique strength athletes, kind of optimizing performance from them. And I was saying this to Brad before he came on, that for me, as someone in the industry, Brad provides a bit of a fresh air in terms of kind of his kind of persona, his personality. Very humble, very grounded, down to earth, and just a genuinely nice guy. And we've kind of been chatting online for kind of probably a good year or so, just kind of on Facebook as you do. And it's good to finally actually get him on and have a chat. So is there anything else you want to add, Brad? Anything you think the audience should know?
No, I think that was a good introduction. I'm super excited to talk to you, Steve. This is, I love doing stuff like this. This is how we get, information out to people in a good contextual manner. And I'm excited. This been a big fan of yours and the work that you guys have done. And so this will be fun. I'm pretty pumped.
Awesome. Cheers, Brad. Appreciate that. And today we are going to be talking about a much loved subject by myself and everyone else, hopefully, which is carbohydrates. And we're going to go for a bit of kind of a basic introduction of kind of some basic concepts behind carbohydrates that I think many of the listeners will probably know of or heard of and kind of get it, but we're going to cover it a bit more kind of detail so you actually know what it is. And then we'll go into some more specific, some more advanced subjects that hopefully a lot of the audience can kind of take away and use for themselves. So the first kind of, in a sense, an easy question, but one a lot of people I don't think fully understand is, what is a carbohydrate, Brad? Like, people talk about carbohydrates, they're like, oh, I'm on a carb-free diet. And when I think of a carb-free diet, I think of something that you basically can't achieve, because carbohydrates are almost found in everything. So if first of all, we just kind of cover, you can go on for a long ramble, I'm sure, and I'm sure we will, but what is a carbohydrate to you, Brad?
Yeah, so we can kind of tackle this from a few levels. And I think it's really important to talk about them in a few levels because, we have biology and physiology, which is how your body operates. And then you have, food in the real world, which is, how you consume and how you actually view things in a normal life. So when we talk about, very basic biology, biochemistry, is carbohydrates are a class of molecules that are basically structures that contain carbon, hydrogen, and oxygen. And for our purposes, they are essentially sugar molecules that have, they are they're very basics. They're either 6 carbon or 5 carbon molecules that, have hydrogen groups and oxygen with them. And they're called carbohydrates because they are hydrophilic molecules. So that means they store and they will hold water with them when they're in their large molecular structures. And then, of those basic structures, you have those small molecules, whether they're 5 carbon like sugars, which are things like fructose, or 6 carbon, which is, more glucose or lactose and things like that. Then those make up larger structures, right? Like glycogen, like starches in potatoes and things like that. So just at a very fundamental level, that's what those things are. And they differ from proteins chemically and functionally, and they differ from fats chemically and functionally, and how they're stored and things like that. So the basic chemistry of them really is important to kind of understand as you walk through a lot of the additional physiology. Now, from a food perspective, right, more of an actual real world perspective, is carbohydrates are, foods that contain these chemicals, right? These chemical structures. And that means, foods can contain almost all carbohydrates or almost no carbohydrates, and they go along the full spectrum, right? So when we talk about things that are like carb-dense foods, you've got things that are very starch-heavy or very simple sugar-heavy. So you've got potatoes, rice, fruit. You've got things like table sugar, which is just purely stripped down, simple carbohydrates. And then you've got foods like green leafy vegetables like kale, broccoli, cauliflower, etc., that they do contain carbohydrates, but per volume, there's not very many. And a lot of them are in, fiber that's indigestible. You've got some digestible fiber. You've got some just normal, simple sugars in there, because plants have sugars because they run on sugar. So, you've got this full spectrum of foods that's some contain lots of carbohydrates and some contain very minimal carbohydrates. So that's kind of the basic overview of what they are and kind of how they fit into a diet or a food schema, so to speak.
No, that's perfect. And I think, you brought up some good points in that. I think a lot of people, none of our audience hopefully are thinking that fruit and vegetables aren't carbohydrates, but I think a lot of potentially more general population almost think of fruit as its own macronutrient, and they just think, oh, fruit's healthy, that's not a carb. Or maybe kind of vegetables, people don't realize how many carbohydrates vegetables can really contain, and things like peas, things like sweet corn, which is delicious, they contain like high amounts of carbohydrates like you were talking about. And something you did touch on that I really wanted to talk about was kind of, you talked about simple sugars and you talked about starches. And kind of in relation, people have probably heard of like slow digesting carbohydrates, fast digesting carbohydrates. Can you kind of talk a little bit more about that, and kind of maybe we can touch on the relevance for someone who is going to the gym and trying to kind of use maybe different ones at different times and the implications behind that?
Yeah, so there's, I'll kind of plant a little bit of a flag up front and say that, this whole idea of simple, fast, is very much more of an antiquated idea. And as we're starting to learn more, right, we understand there's a lot of individual variation, and I'll kind of touch on that in a minute. But there's really there's a few ways to think about it, right? There's the carbohydrate quality and content of the food you eat, whether it's, heavy and simple sugars, or heavy and complex sugars, we'll call them, and then how your body processes those, and then the response your body has to those. So there's kind of several layers, right? The first is, what is it in the foods that you're eating, right? So we know that different foods have different, macromolecular structures. So if you have foods like a potato that's very starch heavy, you've essentially got a lot of glucose molecules that are all bonded together to make these large, quote unquote carbohydrate structures. Or you've got things like bananas or, soda, which has a lot of, very small chains of sugars, whether they're individual by themselves, or you've got some disaccharides, two together, which is like, table sugar, which is sucrose and fructose, or which is glucose and fructose put together. So you've got the full spectrum. And what that means is that affects how sweet food tastes. So like initially when you put it in your mouth, right, if you've got very complex sugars, there's not a lot of free glucose or fructose molecules around. So you don't taste things that are super sweet, right? So you could eat a giant potato that's got 100 grams of carbohydrates in it, and it's not going to taste very sweet, right? It's depending on if you've washed it off or not, it might taste dirty. Or if you put salt on it, it might taste salty. But by and large, there's not going to be a lot of sweet flavor in it. if you, on the other hand, have something that's really heavy and freely available, table sugar or fructose or just simple glucose, it's going to taste very sweet because of how, the chemistry interacts on your tongue and sends signals to your brain, et cetera. So generally speaking, the more complex carbohydrates are in a food, the less sweet it's going to taste. The more simple free sugars that are in a food, the sweeter it's going to taste, right? This is why fruit tastes super sweet, candy tastes super sweet, things like pasta, rice, potatoes, which all have similar carbohydrate profiles in terms of overall carbohydrate load. Yeah. They're going to taste very differently. And that's also going to signal different hormonal releases and change digestion. So, it takes time and it takes chemical and mechanical processes in your body to break down those big sugars. Whereas it doesn't really take that with the small sugars, right? They can be digested and absorbed very, very quickly. So, that's kind of the first way to think about it. And this idea was initially put out, I think it was in the 1980s, was the glycemic index came out, that basically was a very rough tool of, when you eat a food, how quickly and how high does your blood sugar go up? So when you eat any sort of carbohydrate, it gets broken down into sugar, it goes into your bloodstream, and it registers in your bloodstream, right? You can run assays and look at them. So they basically made an index to say, this type of food has a greater response than this other type of food. And so that was used for a long time of, how do we regulate blood sugar post-prandial, post food consumption. Now, there's been some really interesting work to kind of tell us a few things. One is that outside of specific disease processes, glycemic index is not really a great tool for a lot of reasons. And one of them is the individual variation of people and how they respond to either simple sugars or complex sugars is all over the map, right? So there's been a series of 2 studies that has essentially looked at, they've taken a lot of people, hooked them up to continuous glucose monitors so they can just measure their blood sugar all day. And they'll give them things like, like a piece of bread, an ice cream, or a banana. And if it was you and me, you might have a really big spike to ice cream and I might have none. Right. I might have a really big spike to the bread, you might not. So a lot of it comes down to these big intra-individual variations that really dictate how you respond, whether it's just the way hormonally your body's set up, mechanically, how do you mechanically digest food, chemically, how are your enzymes breaking things down, what's your gut microbiome, with that being probably the largest piece. So this idea of, really just taking foods and putting them into, fast digesting or slow digesting kind of starts to break down the more we get into it. So that's kind of probably the best way to think about it right now, is a lot of these ideas of, fast digesting simple sugar foods versus complex, slow digesting foods. They're not quite, put into different spectra, right? They're very overlapping, and there's a lot of individual variation between, people in between those types of foods. So then to talk to your point a little bit about, like performance in the gym, et cetera, a big piece of that is, start with rules of thumb and then work to your own individualized thing that works, right? So a lot of people will find that if they have very fast digesting carbohydrates right before they work out, they get a good bolus of carbohydrates, they can work out longer, they can, train harder. And some people find that if they have that, they get a big spike, blood sugar tanks pretty quickly, and then they don't feel very good. So they need something like a potato or pasta or oatmeal before they train. So there's good ways to start to test things, but then you really have to kind of go down that individual variation. And the other thing too is what you do now in your training isn't what you're going to be doing 5 years from now, right? So keep using those signals and kind of keep improving of how things are moving along as you progress. So I think there's really good rules of thumb to start, but don't ever get locked into this is what it is, this is how it has to be forever.
That's super interesting to hear about. obviously a lot of us, I mean, you hear people saying, oh, I'm going to have, I don't know what it might be. They talk about having maybe some rice cakes and honey before hitting a workout because those are more simple sugars that are easily digested. But I've definitely had clients who have tried that, and then, like you said, they've got into their workout and they kind of crash and they don't feel great. So I think it's great that you pointed out that individual difference at the end of the day rules once you are kind of your own study. So it's good to kind of have a look at how you're responding to things. It's interesting to see, and people talk about it all the time. Bodybuilders talk about it all the time, especially for someone like me. Like, you think about peak week and you hear bodybuilders talking about, oh, how do you respond to like that particular carb when you eat it? Do you get like a good pump from it and things like this? And that's very kind of like, it sounds like a bit of a bro-ish thing for a lot of people, but like you said, in reality, kind of there is that individual difference in response, even between two people who are very, very similar, like both active. It depends on how they individually respond to that. So that's really interesting. And you talked about the glycemic index, and I think something related to that, and we might not want to spend too much time on it because it might not specifically be kind of carbohydrate based, but kind of talking about glycemic load and kind of mixed meals, does that end up kind of scuppering it a little bit? Kind of, if we want to talk about that a bit to the audience.
Yeah, so glycemic index really just talks about like the peak, how high does it hit and how fast does it hit is kind of the way I view it. There's a little bit of nuance there, but for all intents and purposes, that's kind of the way to go about looking at it. Glycemic load is, if you look at the area under the curve, right? So if you map out your blood sugar over 2 hours, 3 hours after you eat, what's the total blood sugar load of that food? And so when you talk more about like exposure for disease processes, total recovery, muscle glycogen replenishment, those types of things, glycemic load is a much more useful tool than glycemic index is. But even then, if your glycemic index, which is eventually it's kind of a piece of the equation of glycemic load, is so variable, and even your glycemic load is so variable over per people, you really can't also just take a glycemic load from a published paper and say, I need to eat this because of this. So there's good tools and there are good places to start, but you probably shouldn't use that as gospel and kind of say, this is what I'm going to do because of this.
Mm-hmm. No, again, I couldn't agree more. That's really, really good. And I guess we're kind of getting on to a point of which, and actually I'll ask the question starting with kind of the statement that carbohydrates are kind of non-essential. So they're not conditionally essential for the body, like protein and fat, we have to get those in. But for an athlete, would like carbohydrates play quite an important role? And if you just want to talk about maybe some of the performance requirements and then maybe even like the health aspects, which obviously are a bit interlinked into performance anyway. So for a kind of physique competitor or a bodybuilder or a powerlifter, what kind of role do carbohydrates play for us?
Yeah, so the statement that carbohydrates aren't essential is kind of one of those things, like it's a cool piece of trivia, but it's probably the most unhelpful statement ever uttered about carbohydrates, right? It's kind of like, there's a lot of things about life that you don't need to survive, but it makes life horrible and you're not ever going to get to where you really want to be. So when we talk about carbohydrates in the diet for, physical activity and performance, when you talk about high intensity workloads over any extended period of time, and that's 2 minutes, 5 minutes, 10 minutes, if you don't have an adequate amount of carbohydrates and you haven't really kind of greased the groove of those biochemical pathways, you're never going to achieve the maximum work capacity in any given sport, right? Now, there's some sports that you could argue you don't really need a lot of carbohydrates because of the energy requirements and the time requirements. But I think those are on the far ends of the spectrum and don't really apply to most people. So I think the idea of, can you get away with doing a lot of activities on very, very low to almost zero carbohydrate intake? I think you can. But I think all of the literature supports the idea that operating at the highest possible capacity for the longest period of time requires, dietary carbohydrates. And it actually requires you to have optimized the biochemical systems in your muscle tissue to use carbohydrates. I think it's Alan who, made the analogy of, if you're trying to produce as much energy as possible, if you're trying to do that with over a short period of time and at a high level, trying to use dietary fat for that is like having a hose of, that's really kinked down and really small, whereas dietary carbohydrates has a much bigger diameter and a lot more water can flow through it. So when you just look at the fundamental biology and biochemistry of skeletal muscle tissue, if you want to produce the maximum work over the shortest period of time, or the most extended period of time, you have to have dietary carbohydrates, or you have to have carbohydrates in your muscles, and that requires you have to consume them. So I think that's a really important piece. Now, when we talk about strictly physique athletes, which is kind of what we want to focus on here, is there's a lot of talk about dietary protein for building muscle tissue.
Yeah.
But there's two other components to that, right? Is one, you have to give your muscles enough signal from training to grow more muscle tissue. And what allows you to train at a high capacity for a long time and accumulate volume? Having carbohydrates in your diet.
Yeah.
The other piece is just building the blocks, building the actual contractile tissue in the muscle requires energy, and it requires carbohydrate. And I think there's probably 20, 25 really pretty well done studies that show that muscle protein synthesis is maximized with protein and carbohydrates present, right? Just having protein there, it gets you a little bit of the way there, but there's very much a additive synergistic effect of dietary carbohydrates in conjunction with dietary protein. So I think if you're a physique athlete and you're essentially trying to, low carb or keto your way to, maximal muscle mass secretion, I think you're spinning your wheels and you're wasting a lot of time that you're not going to get back, right? Mm-hmm. If you spend 22 to 25 trying to do the low carb thing, you're missing out on 3 years of really high quality training time.
Yeah.
So I think if that's the sport you want to go into, don't shoot yourself in the foot, by trying to do things as inefficiently as possible.
Mm-hmm. And then when we're talking about, we talked about muscle gain there, and obviously we need the carbohydrates to fuel training, and kind of training, as we know, is a huge signal for muscle growth. Protein's kind of almost secondary to that, especially for like a newer lifter. When we're talking about fat loss, I guess a large component of that is muscle retention. So in terms of fat loss, what do carbs play as a role there? Because I think a lot of the listeners and myself included kind of we look at carbohydrates as being kind of something that we could have to bring down to be able to lose fat. Is there ever a case where you think, keto could be a better fat loss solution, or would carbohydrates, keeping those as high as possible, always be your go-to?
Yeah, so I think there's a few ways to tackle this. I think the first one we have to kind of, address is the overwhelming amount of evidence that suggests that dietary carbohydrates themselves are not in any way, shape, or form, responsible for fat mass regulation, right? In the context of everything, the role that they play, there's no singular aspect to carbohydrate metabolism that dictates fat gain, right? We know there's just, we won't go too far into those studies right now. We'll probably talk about it in a little bit, but just I think we need to put that flag out there so people, kind of know that's the position we're going for the rest of this kind of conversation. And then after that, when you talk about, dieting down or fat loss for a show, is you have a few things you need to keep in mind. One is you've just probably worked for months to build as much muscle mass as possible. So you need to try to maintain as much of that as possible. So your deficit needs to be the smallest deficit you can have to get the results you want. So I think a lot of people first make the mistake of they go into a huge deficit right off the bat, and they kind of get things started on the wrong foot going into it. And then from there, it really becomes a preference of fat and carbohydrate macronutrients to what is the best thing for you in your diet. Mm-hmm. Now there's you can really pull out carbohydrates or fat and still get fairly similar results. Typically a lot of people find that lower carbohydrate diets are a little more successful for them because you can replace a lot of your like starchy carbohydrates with, very fibrous vegetables, and it's just, makes it an easier lifestyle choice. And that's really kind of what it comes down to, right? There's no evidence to suggest that, a lower carbohydrate approach is going to make your cut more successful, or a lower fat approach is really going to make your cut more successful. When you talk about how you get to ultra lean, states, is you've got to play the balance of managing energy deficits and managing hormone, right? Yeah. So there's a lot of reasons why keeping dietary carbohydrates for that aspect in your diet as much as you can is a good idea, because we know, one of the things that really can start to kind of tank somebody's progress, right? Dropping thyroid hormones, really not a good idea. We know dietary carbohydrates can help prevent thyroid function loss. Cortisol levels, right? What's a good way to look really, really flat and deflated is having really high levels of cortisol. We know carbohydrates are kind of a natural way to kind of fight against some of that, cortisol, muscle breakdown, et cetera, et cetera. So the way that whenever we work with physique competitors, we like to say we need to keep carbohydrates at a level where you can still function. We're not really kind of affecting thyroid function. We're not keeping you in, elevated cortisol levels. And that's kind of the way where you want to play it, is find that level where you can still function and still keep a lot of those things optimized. So that's kind of the battle you're facing. And it really depends on how long it is, right? If it's 4 to 6 weeks, you can get away with being a little bit more aggressive. If it's, 16 weeks out and you're really going to start cutting things, you got to start to be a little more nuanced of, how are you going to do this? Are you going to have weeks where you do eat more carbohydrates, et cetera, et cetera.
Okay. No, yeah, brilliant. And I think that's a really good point you made about kind of, the fact that carbohydrates, they fuel performance, but they've also other roles that you might not realize that they're doing for you. And I mean, you see some competitors coming into shows and kind of, it's like the last trick they play is like going into keto, because kind of they're like trying to get into those ultra lean levels, and they kind of see it as a tool to get there. Are we saying that you don't need to do keto to get to those lean levels? It's more of a fact of you keep your protein high and you get your calories down. How you do that is very much individual.
Yeah, I mean, that's exactly right. So there's very good evidence to suggest that. And most of it is, so they've done studies where they've looked at, just low carbohydrate, and does that, improve fat loss? It doesn't. Then they've done studies where they've looked at low carb, not in keto, and then, low carb keto, and looked, does a ketogenic state itself have any additional properties in terms of, managing fat loss or managing muscle tissue? And from what we can tell from the data right now, it doesn't appear to be. There are some hints that, being in a ketogenic state might start to preserve a little more muscle mass versus just low carb, because of some of the biochemical things and, some of the hormonal things that can happen when you're in a ketogenic state. But those studies are pretty short term, and a lot of those are, conjecture at this point based on some biochemical mechanisms we see, and then saying, okay, over a long period of time, this is probably what's going to happen. There's some evolutionary support, like, in evolutionary times, what would happen and some things like that. But when you talk about what that means in 2017, and, what people are doing now, I don't think the potential tiny advantage of sparing muscle tissue in a ketogenic state, especially for like 2 weeks as a last cut, I don't think that's anything meaningful over, a lower carbohydrate approach. So there's, at least from what I know, I have not seen any compelling data to say if you're not in ketosis, you're not getting the maximum effect, because I don't think those potential, mechanisms actually extrapolate into anything meaningful, especially if you're stepping on a stage in 2 weeks. I don't think those last 2 weeks need to be, I don't think you're getting any additional advantage.
Cool. No, it's really interesting. And something else you actually talked about, I kind of touched on it a little. Well, we didn't really touch on it, but the thought of the role carbohydrates play in a contest prep, and talking about maybe, do you ever use things like refeeds or diet breaks in which you do maybe keep protein and fat pretty much level and then just have a higher carbohydrate intake to try and mitigate some of the metabolic adaptations occurring. And if you do use refeeds or diet breaks, what do they look like for kind of your athletes?
Yeah. So whenever we have people who are in, long periods of dietary restriction, I do think that kind of carbohydrate refeeds make sense, especially if you're, kind of a physique athlete. A lot of this stuff is anecdotal and conjecture and experience, because just really well done studies with refeeds. I think there might be one that's been fairly well done, but is not really long term. But I think when you look at how that functions, I think, having periods of higher carbohydrate intake make a lot of sense, right? It can help, kind of, for lack of a better word, top off the glycogen tanks, right, that you kind of been depleting during the week. It kind of offsets some of the hormonal things that can start to add up. Mentally, it's really good for people, right? Because they know, okay, I'm going to have a few days where I feel like garbage. I'm going to have 3 or 4 days where I feel fine, and I can get through the training, and I can take these as my rest days, et cetera, et cetera, et cetera. So I think for a lot of people, some of those cyclic refeeds during periods of restriction make a lot of sense. There's some cases where you might not want to do that due to behavior things, that those can actually kind of, a lot of times when you're restricted, if you say, hey, go have, a pizza turns into ice cream, which turns into the rest of the freezer, which turns into 2 weeks off plan. Yeah. So, it's contextual, right? Yeah. So I think having that as a tool and managing it really well can be a very powerful tool for a lot of people.
Cool. And when you're talking about maybe refeeds and diet breaks, do you favor one over the other, or is it very much like individual? Do you have any kind of just general rules of thumb that you personally use with clients, anything like that? I'm more of a fan of, take a little diet break rather than, just having a carbohydrate refeed, because I think, getting them just a little more calories in general, some additional fat, some additional carbohydrates, you're going to get virtually the same result as if you just add the carbohydrates back in. Your body is so robust to a lot of changes that, if I just add 300 carbs today, but that's really not any different from an additional 15 grams of fat too. So I'm more of a fan of a little bit of a diet break. But that's just kind of my style. And it's also the clientele that we work with, right? Yeah. I mean, I'm not working with the Phil Heaths or the guys who, have to have the last 0.001% dialed in. So there might be some arguments or rationale based on experience and how those people respond, but at least that's my perspective as it currently is. Yeah. No, I agree. I used to use refeeds more so, and then as kind of more research come out and I've practiced it, I've found diet breaks to have way more of a successful kind of approach to my clients. And it really helps for the people that maybe binge from refeeding and find that kind of a bad habit for them to get into. The diet break kind of gets around that issue as well. So no, it's really interesting. So we are coming to, we've come to an interesting point at which we were going to discuss kind of keto anyway. And that's kind of where we were kind of touching on keto already. And I think a lot of people kind of hear it and they don't really know what it means. And so I know you know a lot about keto, and kind of we were going to touch on what actually, like, to be in a ketogenic state, what does that actually require? What does that actually mean for someone?
Yeah, so there's, when we just talk about ketosis, right, or a ketogenic diet is essentially you consume a diet in a specific way that causes your body to produce ketones that kind of pass an arbitrary threshold. And then you have certain organs, specifically your brain, that are going to run more on ketones than they are fatty acids and carbohydrates. Now, usually what that means is if you pull out carbohydrates, right, it doesn't really have any – before we go down that rabbit hole, I'll address this. Most people think it's, it's a high-fat diet. No, it's actually a carbohydrate restriction, right? If you eat nothing, your body's going to go into ketosis. It has nothing to do really with the dietary fat consumption itself. It's the restriction of carbohydrates and the restriction of protein. So essentially, it's a diet where you need to get enough calories to have energy to survive, but you want to put your body into this ketogenic state where your body's running on ketosis. So you consume mostly fat for energy and enough protein that you kind of stay under the gluconeogenic process. And your body runs on elevated ketone levels. So that's essentially what it is, right? The history of it is, it's cyclical, right? Keto was back in the 80s, 90s, went away, it came back. It's been used as medical therapy for, pediatric epilepsy. And I think that literature is probably the most well done because it's, in medical application in kids. So you've got to have your research methods on point, and you can learn a lot from that stuff. So that's kind of what a ketogenic diet is, right? It's just consuming food in a manner that you restrict so much carbohydrate that your body's running mostly, or specific organs are running mostly on ketones and fatty acids. So there's a few points that I want to make. Is we'll start kind of in the most proximate sense, and then we'll kind of move to bigger issues. Is it's marketed as a fat loss tool, and it's marketed as that because the idea of if you eat more fat, you burn more fat. Yeah. So it's true, right? If you are in a ketogenic state, your body is utilizing more fatty acids for fuel than if you're not. But that doesn't have anything to do with total fat balance in your body. It's just short term or even long term, your body's just using more fatty acids for fuel. But if a lot of other things aren't different, the net fat balance doesn't change, right? Your body's still holding on to fat. It's just sending other molecules around to do other things, and then the fat mass is staying the same. Yeah. So you can easily gain weight on a ketogenic diet, right? I mean, it's been done by a lot of people for a long time. So that's the first piece. The second piece is, I think at this point, there's been enough research that we can make very solid conclusions. And whenever people post things, I always make a joke, when there's a new keto study out, I'm like, we funded another one. Like, we got it. We know what's going on. There's a lot of nuances that we need to kind of work out, some mechanisms, some potential for, therapeutic places in medicine. But when we talk about like weight loss, what's better, what's worse, it's very clear, right? Yeah. A ketogenic diet, when you have all the other variables accounted for, does not offer any meaningful advantage for fat loss. There's some contexts in terms of just lifestyle that people may consume, spontaneous caloric reduction. But the overwhelming evidence just suggests that there's no real additional benefit to it on top of, calorie balance, adherence, lifestyle modification. You're usually eating more fruits and vegetables, usually more vegetables, not a lot of fruits. You're being a little more mindful of your choices. It usually comes along with, people get interested in changing their health. They start working out more, et cetera, et cetera, et cetera.
And when we're talking about kind of carbohydrates need to be low and protein needs to be at a certain low level, how low are we talking? Is it individual dependent? Is it kind of a percentage of calories it needs to be for that individual? Or is it kind of, it's 50 grams you hear a lot of the time? What does that level mean for people?
Yeah. So I'm kind of the mindset that percentages are kind of meaningless, right? Like, we don't eat percentages. We eat like absolute amounts of food. So I think the first thing is look at things from like absolute perspectives. We're just so trained of like, eat a 30% diet, so that's just kind of what's been ingrained. But I think the better way is to look at absolute numbers. The truth is there's a lot of variation, right? Is each person's, level of carbohydrate consumption for being in ketosis is different, right? So yours is different from mine based on lean body mass, total body fat, hormones, training level, etc. So it's really different. If you eat less than 25, you're pretty much guaranteed your body's going to be in 25 grams. Your body's going to be in a ketogenic state. Some people, depending on, if they're like high level athletes training 4 or 5 hours a day, I mean, if they can be in a ketogenic state at 200 or 250. Like, I've seen some really crazy data just because their body's using all that circulating glucose so quickly because they're training for 4 or 5 hours that they just have to start breaking down fatty acids to just supply ATP and things like that. So it's just like with the glycemic index, it's a distribution, right? As some people have very, very low requirements, and some people can get away with a lot. So it really depends. And the same thing with protein, right? Some people, they have, they can eat 150 grams of protein and stay in ketosis. Some people, have 2 bites of beef jerky and it kicks them out of ketosis. So, it really is very dependent. And so that's why, even when you're doing ketogenic diets, a lot of it's, you got to test your blood levels, right? You got to just see what's going on. So there's no hard number. The best way you can guarantee it is don't eat any protein, don't eat any carbohydrates, and your body, that's the only option.
And that would suck so bad. And I think what we've kind of already been telling the listeners is that the aim, if you are going for a ketosis style of diet, the aim isn't necessarily to get into ketosis anyway. It's to get into a calorie deficit. If that's what you're aiming for, fat loss, it doesn't matter if you get into ketosis or not. You're just finding a diet solution that works for you for that solution.
Yeah, and that's really what it is, right? So that arbitrary, millimole value of beta hydroxybutyrate in your blood from a weight loss physique standpoint is probably one of the most meaningless outcomes you could do. So like if you're every day basing your diet based on the number on that, ketone meter, you've kind of lost perspective of what you should be focusing on, right? It should be focusing on training quality, nutrient quality, calories, how you're looking, how you're feeling, how you're training. And if for some reason your ketone levels are up, that's just what it is. It's kind of a distraction, I think, for a lot of people.
And the final point I wanted to investigate a little bit here was people talk about keto flu. Is that kind of something that is a real thing? I relate it to kind of like brain fog when you're dieting and you're on low calories. Is there something people go through when they don't have enough carbohydrates available to fuel kind of brain function and they're not adapted to using ketones and they actually feel something like really bad, essentially?
Yeah, so this is great. We can kind of kill 2 birds with 1 stone. I'll talk about kind of the keto flu and what happens, and that'll kind of segue into this argument that people make all the time about keto adaptation. And hopefully this podcast can be used to kind of nail that coffin shut, because it gets really irritating at times. So your body is very dynamic, right? Like if you eat a really high carbohydrate meal, your body's going to use carbohydrates. If you eat a really high fat meal, your body's going to use dietary fat. Like you adapt. So when you go from eating a very mixed diet of carbohydrates and fat and protein, the molecular machinery in your body to take those nutrients, go through all the chemical processes they need to spit out the metabolites and spit out ATP for energy, your body's used to what it's doing. So it has the right enzymes, the right amount of enzymes, the right molecular machinery to process that and create energy. So then when you shift completely to some new substrate that starts to predominate, it takes a while for your cells to adapt to those things. Now, it actually happens pretty quickly, right? And we'll talk about this in a second, but that's why, the keto flu or the carb flu is usually a few days, maybe a week, right? Is your molecular machinery catches up, because if it doesn't, your cells die and you die, right? So things happen pretty quickly. So the carb flu it's a real thing. It's just a process of your body going from, running on one type of fuel to running on a different type of fuel. And the adaptation has to take place. So it's a very real phenomenon. Some people experience it a lot worse than others. Some people don't experience it at all. So it just shows, the individual variation again, which, brings us to the next point. So a lot of these studies, especially when we talk about, physical performance or even weight loss or fat loss, people talk about, it wasn't long enough, people weren't keto adapted, which means have they gone from using carbohydrates as a main fuel source to, ketones and dietary fat. So when people say, they weren't keto adapted, well, what does that mean, right? There's markers and there's outcomes that we can say, this is what should happen if you're keto adapted, right? First thing is your body should be, having elevated levels of ketones. That means your body's in ketosis. The second thing is your overall metabolism should shift to fatty acid metabolism. And we can measure that by looking at, respiratory exchange ratio. And we can also look at some blood markers of that. The next thing is going to be insulin levels, right? Are your insulin levels lower? Because if you're not eating carbohydrates, your body shouldn't need to be producing a lot of insulin. Mm-hmm. Then you've got your actual cellular machinery. So you should have an increase in, ketolytic enzymes, fatty acid oxidation enzymes. You should have increases in mitochondrial biogenesis, right, which is one of those fancy words people throw around. And there should be a reduction in carbohydrate metabolism enzymes, right? So when you look at the literature and people say, oh, people weren't carb or keto adapted, you can find all of those things in the literature, right? Like they're there. We have all the papers, we have all the data we need to make some fairly robust conclusions. And we know that, ketone levels increase in the blood within, a couple days. Insulin levels drop within the blood in a couple of days. Mm-hmm. You reach a new kind of steady state RER or, fat to carbohydrate fuel mixture within, a week. Your molecular machinery within your muscles can change, depending on the paper, within like 3 to 12 days. So when people say 2 weeks wasn't enough or 4 weeks wasn't enough to be keto adapted, it kind of blows my mind. It's like either you haven't read the literature or you just don't understand what this means. Mm-hmm. So we really do have this pinned down to your body can shift from being a carbohydrate utilizing physiology to a ketogenic utilizing physiology and function at a fairly normal level pretty quickly. Now, when you talk about very high-end performance, et cetera, it might take longer to be adapted, but for most of what we talk about, we have that window pretty nailed down, and we kind of know the answer. So it kind of, that lately has been one of the things that I just want people to get is this idea of keto adaptation. You have to know what that means. Yeah. And then when you actually do know what that means, we have the data to show you that it's within 2 weeks is probably you're far into the adaptation period.
Mm-hmm. No, perfect. And I think that, definitely puts a nail in the coffin. Hopefully, we can use this to send out to any people who are kind of being a bit confused with it, and people who are kind of, keto lovers in a sense can do with hearing some of the stuff that we're talking about, because I think it's really powerful. So we talked about insulin, and actually that is an interesting kind of subject for a lot of people, and in relation to carbohydrates, especially for kind of like fat loss and physique competitors. When we're talking about carbohydrates and insulin, and maybe even talking about elements of, you talked about during your workouts, you're kind of using carbohydrates for fuel. Is there anything physique athletes need to concern themselves in terms of, like, during your workouts, how depleted do we get? Do we need like a insulin spike post workout? Is that something we have to be concerned about? What role do carbohydrates play with that? Nutrient timing is something that maybe we can touch on here with our carbohydrates.
Yeah, so I think probably the best way to think about insulin in terms of physique athletes, there's kind of two ways to think about it. One is it's kind of like a fuel selection switch, right? The normal baseline level of your body is you're using more fat for fuel than carbohydrates, right? So you're always burning a little bit of both, and you're always using the creatine phosphate system. Like they're all going at the same time, cool. But just at baseline, if you're not eating, you're not working out, you're not doing anything, your body's using more fat for fuel. Then when you go into a fed state, like, right, you eat carbohydrates or you eat protein and your body signals insulin, it's essentially a signal to your body to, hey, we've got nutrients coming in that have a finite storage capacity. So we can start using more of those for fuel because more is coming in, we can replace it, cool. And we're good to go. So that's really the way to think about insulin itself. At normal physiological levels of insulin, right, not like injecting, high levels, insulin in terms of muscle growth is more of it prevents catabolism, so it prevents breakdown rather than it stimulates accretion. Cool. That's kind of one of the thoughts people think, take insulin or elevate insulin and it really increases muscle growth. It actually just kind of prevents breakdown. And it also just shuttles more sugar and more protein into the muscles to kind of let it refill back up. So that's kind of the best way to think about it. So when we talk about kind of post-workout, almost all of the interventions when you kind of look at more long-term, so we don't, unless you're training multiple times a day, what's the big thing we care about, right? Are you fully recovered by the next day?
Yeah.
So whether you optimize post-workout insulin signaling by getting, a high glycemic index carb with whatever that means, to fuel glycogen replenishment, it doesn't really matter how quickly you do it, or how optimal your carbohydrates are. As long as you get enough within the 24-hour window, your 24-hour glycogen repletion is going to be pretty much the same whether you're eating really high glycemic or really low glycemic. Mm-hmm. Now, shorter, like if you're training at 10 a.m. and then at 2 a.m., it makes sense because it'll speed it up.
Yeah.
But over 24 hours, it's not super important. And, Brent Ruby over at University of Montana, he's done some really interesting work in this area, kind of showing a lot of that, over, decades of muscle biopsies of looking at that. So that's probably the best way to think about it.
Mm-hmm. No, that's really interesting. And then in terms of when you're working out, how kind of glycogen depleted are you even getting? Maybe if we talk about someone who is in maybe contest prep and they're doing a general kind of hypertrophy workout, how likely is it that they're completely depleted? Or how many carbohydrates we're using within a typical workout?
Yeah, so I think the first thing is you'll never reach full glycogen depletion. Like, I don't know if people remember back to very basic chemistry, right? Is reactions always proceed from products to reactants, and it's always on a concentration scale, right? So if you have, let's say, 500 grams of carbohydrates in a muscle tissue, that's not realistic, but for this purpose, the lower you get in that, the lower the reaction is going, right? You don't have as much pushing the reaction. And so you're never really going to fully deplete it. Even if you're completely starved, you're still going to have muscle glycogen around. Your muscles just won't function. Now, how much you actually deplete it in a workout that's a really good question. It depends a lot on the type of training. If you're doing like very high volume bodybuilding training, I can't remember the data off the top of my head, but I want to say, 60, 70% is probably, not depletion, but like you'll have left at the end of a training session.
Okay.
I think I'm sure somebody will have a better answer than me since I haven't looked at that literature in a while. But the other thing is, depends on what you're doing during training too. Are you consuming exogenous carbohydrates? Yeah. Because if you are, that will kind of negate some of that loss. So it's really nuanced, but most people don't get past half, but that's still quite a lot, right? If your body's if you're a fully grown man and you weigh 200 pounds, your overall muscle glycogen capacity is pretty big, so you can be missing 200, 300 grams, maybe 400 depending on how things go, of total muscle glycogen levels that you have to replace within 24 hours between your next training session.
And then I don't know how much you personally have experience with this. I know we spoke about this just beforehand, and this is kind of getting into an arena that kind of peaking for bodybuilding potentially, and we're talking about depletion of muscles of glycogen. Is there mechanisms in which they super compensate? And what is kind of how depleted do we need to get for that to occur? And what is the level of supercompensation that we can typically see? I don't know if the listeners might know like Lyle McDonald and his like Ultimate Diet 2.0, and you probably have read it, Brad. I imagine you might have. And he has his kind of like depletion workouts, which you were talking about, and they're very low carb days and kind of doing lots of activity. And then he has like kind of carbohydrate loading days in which you kind of look to super compensate. What's the mechanism behind that, kind of where we're kind of draining our muscles of glycogen and then almost filling them up with even more than they could have filled up with?
Yeah, that's actually a question I don't have a great answer to. I know that the research has been done. I'm not super familiar with it, but I do know that you will supercompensate, right? Is you'll actually end up storing a little bit more for a short period of time than you normally do, and then it'll kind of proceed back, right? That's kind of just how physiology works. Is you'll you'll have a supercompensation and then it'll return back to normal. The exact mechanisms behind that, I would imagine some of it has to do with insulin sensitivity. Some of it has to do with, just overall energy balance, hormonal things like that. So that's a great question. I'll have to go look into, but I don't know the exact mechanisms by which it works.
Well, no, that's totally. It's good to be honest. Like that means a lot, and maybe it's an article for future, or maybe a podcast for future once you've investigated a bit further. That'd be really interesting to talk about. I don't know if you've got time to touch on. I know you are writing an article at the moment about nutrigenomics. I don't know if you've got time to just touch on that a little bit, or if maybe we can do that in future.
Yeah, no, I've got time. We can kind of run through it. I think, not very many people have tried to tackle it because I think a lot of people, especially in our field, it's very new. But since I spent some of my time in kind of systems biology, personalized medicine, I think I can kind of give at least my perspective. So I think I'll start kind of just painting the landscape in, this idea of, nutrigenomics, I'll call it performnomics, right? Like performance based on genetics. It is undoubtedly the future, right? We're going to start learning more based on basically big data. But right now, we're not even close, especially when it comes to exercise, performance, and also nutrition, right? And there's a lot of important things to talk about. One is it's not all about your genome, right? Your DNA is just one layer, right? You've got your genome, then you've got your transcriptome, which is all the RNA that it produces proteins, it regulates itself, it regulates the genome, etc. Then you've got your proteome, right? What proteins are you producing? How in concert with other things in cells and overall organisms, how are they interacting? Then you've got your metabolome, right? How are things being metabolized? How are those metabolites then influencing your proteome, your transcriptome, your genome? So it's this big, complicated, mess, right? And everything's affecting everything else. So, to just look at the genome and say, oh, you need to eat a 60% carbohydrate diet because your genome, we just don't have that data. And I'll kind of try to explain why. So when we talk about human metabolism, it's a very complicated thing. Now there's some genetic mutations that are called, monogenic diseases. So things like cystic fibrosis or phenylketonuria, right? The maple syrup disease, where you have a mutation in a very important enzyme in your metabolism that basically shuts off the body's ability to do that, and it causes a disease. Right. Those are fairly easily understood, right? We have a singular cause, we have a singular mutation, we have a singular disease. But when we talk about, global metabolism, it's a lot more intricate than that, right? So just because you have an allele that might make you produce one enzyme that, at a little bit higher, right? You might have an additional copy number. That doesn't tell us about the overall context of your physiology. So we just don't know that because they are very complex phenotypes, right? They're just super complex. The other thing is when you look at a lot of the data, like, so if you are somebody who's looked at genomic data, like the GWAS studies where they try to identify, alleles, which are essentially what, single nucleotide polymorphisms are what we based all these nutrigenomics on. And you look at those alleles or those genetic variations that people say explain things, you can actually quantify how much of a phenotype they explain, right? So things like cystic fibrosis or, the maple syrup disease where it's a mutation, it's 100% explanatory value, right? This mutation from an A to a G causes this disease at 100%. So everybody who has it has this disease. A lot of the stuff we're talking about is 0.4% to maybe 5% to, I think maybe the most is 10% explanatory value. So that even tells you that even if you have it, you have a 10% chance of having a phenotype similar to what's being produced. So we are a long way from nutrigenomics. That doesn't mean we shouldn't keep doing it and we shouldn't keep getting tests and we shouldn't try to commercialize it and do things, but we need to really understand where we are and not kind of oversell the promise, because I've had a lot of people send me the results and they say, oh, I've got this, I should do this. And I'm like, well, you're not an endurance athlete, right? You're an MMA fighter. So if you try to go, on a very, very low carb, high fat diet because of this, your career is going to just tank. And they're like, well, this is what the genetic test says. And they said, well, that means you've got maybe 1% of this phenotype is explained. Like,
brilliant.
This is not going to work. So, having a lot of context and really understanding what these things mean is actually super important.
No, that's really interesting, because I know, if we put I know the genetic testing, and I think it's Charles Poliquin's got his, I've forgotten what he's got, Biosig, I think it's called, which gets, in our kind of little niche, it gets quite a lot of hate against it. And like you said, there's very little evidence to support those methods and tools, and they might be like you said, they probably are the science of the future, but very much the future, and there's little to understand about them right now, it seems. I know I've heard of, and I've actually got the book, I bought it maybe 5 years ago, it was the Metabolic Typing Diet. So it's all of these, and it was like a questionnaire I had to go through. I remember each page had different questions, and it would tell me exactly what I should and shouldn't be eating. So you're basically saying that, I guess in this article, which it will be live on your website, I guess in, I don't know how long, but we'll definitely make sure I link it once it is live.
Yeah, it's going to Slow Twitch, the endurance training website. So it should be up. I don't know. It was supposed to be up weeks ago, but I haven't heard. So.
Well, once it is live, I'll have to get you to send me the link so we can put it in the description box below. But I guess your summary of that is it's definitely the future, but right now it's way off in the future, because there's just very little kind of evidence to support kind of the recommendations it can provide. Yeah,
I think we're going in the right direction. I don't think we have enough information to make solid conclusions yet. I think we need to spend a lot more time and money and intellectual capital in trying to figure it out. And I think that's going to be a piece of kind of the personalized medicine of the future. But we just have a lot more work to do to wrap our minds around how these things actually work. And then what does that actually mean for the average person, right? Is a 5%, penetrance, what we call it in genetics, how does that dictate how you live your life and the decisions you make, right? Is that going to say, if your genome test tells you should be this type of athlete, but, you hate doing that type of sport, is that enough to drive you to be like, this is who you need to be? Or can you do something completely different? So
very interesting. I can't wait to actually read that myself. So it's definitely the future. And I've got two questions for you now, and this is where we're closed. The first question is just related to what we've been talking about. What is your favorite carbohydrate source?
Probably ice cream.
Ice cream. That's a cheat, I think. There's far too much fat in your ice cream for it to be called a carbohydrate.
I don't know. I'm a big fan of potatoes.
Potatoes, so, nice. Yeah. Awesome. And then second question is, if people are trying to reach out for you, Brad, where should they find you? Where's the best place?
If you want to read most of the work I've done, it's sciencedrivennutrition.com. And then all of our coaching platform is eattoperform.com. So that's where you can find me. Probably the best way to get a hold of me, like if you want to talk to me or ask me a question, is just find me on Facebook, shoot me a message. I respond to every single one I get, unless it's somebody trying to loop me into a multi-level marketing scheme. But other than that, I will get back to you. So you'll
get all these genetic testers coming on to you, and you're like, do you not know who I am? No, brilliant. I'll make sure that's linked in the kind of description below, and I can vouch for that. Like, I think I don't know if it was me or you who contacted each other first, but we talk over there, and Brad's very approachable. So I know you're on Instagram as well. We can get those links below, and I hope you do reach out to Brad, and thank you so much for coming on. I'm sure you can kind of come on in future and we can have some more great discussions.
Yeah, absolutely, Steve. I really appreciate it. It was a great chat, and hopefully people can get something out of it.
Awesome. Cheers, guys. Thank you for tuning in, and we'll catch you shortly.